Let us now have a look at a fairly complex model. I have opened up readily available engine cooling system Simulink model, and what you see here is a combination of some green part along with orange one, which are nothing but the thermal part. So an engine cooling system is actually modeled like this, and probably with visual inspection or just by observation you will be able to understand what is happening over here. So this is an engine block. Here you have an oil pump, and here you have a coolant pump. This is an oil coolant heat exchanger, and this is a radiator, and there is a fan over here which is implemented by this fundamental blocks, including the lookup table. So basically what is a lookup table? It can be a table which will give you the data, or which will actually be the comparisons or the functions for what value of the pressure or for what value of vehicle speed, what is going to be the output case, right? So with the given inputs, let's say the vehicle speed and the fan, then based on this U1 and U2, what is the output, right? So that is implemented as a 2D lookup table. And if you see the air related system, which is fairly based on the fundamental Simulink blocks. So what you see here is the area air, and that is something related to what we discuss as defining the variables as part of the script or the model workspace. So here we have an engine cooling system, and because if you see this cooling system is fairly simulated for 15,000 seconds, and which is going to take much amount of time because there are so many parameters or so many equations to be solved by the MATLAB, and it has taken so much of time. But the point I'm trying to explain you here is how to visualize the results, right? So look at the engine cooling systems, right? So here we have many parameters, and we have many other things like a cylinder wall temperature, and this is what is the plot of cylinder wall temperature at the end of 15,000 seconds, and which remains continuous to almost constant to around 95 degrees centigrade. So this is the overall simulation, and this is just one parameter, but we'll be able to get so many parameters and their results plotted by Simscape Result Explorer. So what is a Simscape Result Explorer? So let me open the Simscape Result Explorer for this part, and that can be opened by using this part where you have the model properties, and here you have the Simscape Result Explorer. So all those results will be available over here, and they can be plotted like this. Or it is also possible to use this script or use these commands to plot, let's say, the density of coolant, or maybe you want to plot some temperature and mass flow rate. So if you plot some temperature and mass flow rate and the coolant density, these plots are going to look like this. Now you may be surprised that the Simulink results are now different, right? So here we have this one window, and other one is this window. So this one is a normal scope, so this is a scope output, and the other window which you see is a Simscape Result Explorer output. So what is a Simscape Result Explorer? Simscape Result Explorer is another important feature where this is how the window will look like when you open up the Simscape Result Explorer from the previous command. Now what you have to do is you can actually see all the parameters, right, from the engine or maybe the cooling system or maybe any other system, right? So let's say you plot some heat to oil, and that I parameter is plotted like this. And probably if you are interested in radiator for cooling, and all your radiator related parameters are plotted like this. So Simscape Result Explorer, which is this window, can be effectively and efficiently used to visualize all the parameters. So whether you plot it or not, the Simulink in the backend is going to have all the record of all the data, all the models, and all the parameters will be available for us to visualize. So this is about the Simscape Result Explorer, and if you go in detail, probably you can see many parameters, right? So what happens to the temperature of the tank, what happens to let's say the P parameter, it remains almost constant, what happens to the U, and what is happening to the volume, right? So all these parameters are available over here, and you can visualize them from here. So this is just the introduction to Simscape Result Explorer. Let us now learn how we can actually input the parameters from various options. So one thing is, whatever we have learned is actually how we can use the script file and the workspace itself to input the parameters. The other important things are we can actually use the Excel spreadsheet as well to input some of the important parameters. So if you have an important data in your Excel sheet, it can be directly imported to a model. So let me open a new Simulink model, and in this model what we are going to use is, let's take help of spreadsheet and we can use it as from spreadsheet. So this is from spreadsheet option available, and it is also available from the workspace, right? So if you have some data already available in your workspace by your script file, you can use the same workspace variable or data to the model itself. So let's now learn about from spreadsheet and from spreadsheet. So now let's use the Excel input, and what we have to do is just from Excel or from spreadsheet, and we have to give the file name, and let's say file name is 1. So we have the file name. I think I need to give a proper extension also, so I'm changing it to 1.xlsx. so this is going to be my Excel file, and maybe you are wondering that where is that Excel file, right? So right till now I haven't created it. I need to create it in a folder where I'm going to save this model, and this is going to be the input from the Excel, right? So if you double click on this, here you have the file name, and if you click over here you can open up the folder as well. So we have opened up the folder, it's a new folder, and let me create a new Excel spreadsheet which is 1, and this is going to be the case. This is how I can link as well. So probably now we have created the Excel sheet 1, and make sure that the output data type is also like auto. You can change the data type as well. You can change the interpolation and extrapolation related parameters from here, and you can treat the first column as time as well. So let's now input some data in the Excel sheet and enter some output values. So now here I am in the new folder, and it's 1, and I have opened up an Excel sheet 1, and here I'm going to enter some data. So let me enter some data as time. So let's say we are having the time variation from in the step of 1, and that is up to, let's say, 104. So I have created 104 number of time data points, and I can now enter probably any other values. Let's say here are 2, 4, 6, 8 and something like that. So here I am entering continuously increasing values. Let's say I'm doing it up to, let's say, 31, and after 32 I have now again a linearly increasing value. Let's say 1, 2 and 3. So this is how I am inputting my data, and this is just a random input just to see how the Simulink treats this data. So we have saved the one file, and now we are ready to go back to our model, and here I'm going to save the model as let's say test with the Excel. So it's going to be test Excel, and now I will actually add up the Excel file over here, and I want to see what is the output of this Excel. So I'm going to directly connect this with the scope. So what we are going to do in this simulation is just plot all the values, right? So we have something the data related to up to 104, so I'm giving the stop time to be 110, and let's run the simulation and see what is available in the scope. So now my Excel sheet has been read, and here we have the output data available. So initially it went up to 60 at a faster rate, and now then it started from 1 to 3 and it went up to 80. So this is what we have given as the input data, and this is what we get in the output. So you can use the from spreadsheet as well, and in the similar way you can actually export the data whatever is available from this data logging as well. So you can use the data logging and you can get all your data in the workspace. Let's do it for one of our model. So I'm going to open up the gear transmission block again, and whatever is the output data, let me run this simulation. So we are running this simulation, and whatever is data available from the scope, that can be logged into the variable. So here is how you can use the data logging. You have to use this configuration properties, and from here you can go to logging, and you can enable log data to workspace, and it is going to be a data set. So the variable name is going to be scope data, and now you have to run the simulation again, and the scope data will be available in the Simulink workspace. So if I go back to Simulink workspace, now we have some data available as scope data. So here is a scope data available in the workspace. It's an out data set, and here you can find out the scope data, and if you click on the scope data, here you will have 1 and 2 signals, and they are basically all the values available as data set, right? So if you click on the values, you will get all the values, and for my simulation I kept it 360 value constant, and that is what we are getting in the data. Now this is going to be the workspace, and from here you can actually copy your data and maybe paste it to an Excel sheet as an output result. So this is how you can use the Excel for taking the data in and out.